Hi guys. Okay, we made it to Unit 3. So our next body system is the skeletal system, and we'll actually, before we get to specific bones, talk about just bone itself and some of the functions and some of the different types and just all those things before we get to actually the parts of the skeleton. So first off, your bones, kind of a big deal. So first off, they give your body its shape. Remember, without your bones, you'd just be like kind of a sack of tissue. You'd kind of flop around, wouldn't be real great. So your bones support your body. They also cradle your soft organs, and so they are protection. For example, of course, your skull provides an enclosure for your brain and kind of just holds it. Your vertebrae surround your spinal cord, and then your rib cage protects your organs, your heart, and your lungs that are in your thorax. And so, major protection also for those soft organs. Movement-wise, they provide a place for your muscles to push and pull against. So they're levers for your muscle contractions. Mineral storage, I know we've talked about most of these, but remember that your bones are a reservoir for minerals, mainly calcium, but also phosphate. And these minerals are constantly being deposited onto your bone, but then withdrawn and transported by the blood for cells that need them for different cell functions. And so it's a constant kind of give and take between your bones and the rest of your body. And then finally, blood cell formation. This occurs in the marrow, the middle essentially of certain bones. And so your red blood cells are produced here in the majority. And so that's, again, another big thing to keep you going. Okay, so now you do have some cartilage, and some of you are a little more familiar with this if you have had a cartilage injury, excuse me. But you do have cartilage that remains. Now, initially, our skeletons are made of cartilage or these different fibrous membranes, but most are replaced by bone. And there are three parts or three types that are not. And so you do still have some cartilage in your body. The first type is hyaline cartilage, and it's very strong, very flexible. It covers the ends of the bones and movable joints. So you have some in your ankles, some in your knee, but we'll talk about another type of cartilage that is also there, but knees, shoulders, hips, all these places where you have joints that move. There's hyaline cartilage that protects the ends of the bones, helps it to move smoothly, and cushions. It also, hyaline cartilage connects your ribs to your sternum, so there is some flex, so the ribs can kind of move a little bit as you breathe. Forms your larynx, which is your voice box. It reinforces your trachea, which is the tube that is what you're breathing through, your windpipe, and then also the bronchial tubes that are down into your lungs, and then it is your external nose, so it is kind of that movable part on your nose. All right, then elastic cartilage, it's very, creatively named. It's more elastic than the hyaline cartilage. And so this is found in your external ear. So again, it doesn't feel real different to us, but it is structurally a little bit more elastic. And then your epiglottis. And this is the little flap that covers your trachea when you're swallowing food. It basically keeps food and liquids from going into your lungs. Now, it doesn't always work because it is also trying to let air out as you talk and all that kind of stuff. So that's, if you talk and eat at the same time, or you laugh while you're drinking something, sometimes your food and water, or, they don't go to the right place. But that's what your epiglottis is trying to do. And then finally, your fibrocartilage. This is very compressible, so you can really, really press it down. It also can really handle twisting and turning. So you see a lot of this in your knee because of the movements that your knees have to make. And then also, especially for the compressible part, in the discs between your vertebrae and your spine. So, so each type has a very specific structure and also a very specific location and function. Okay, so here is the picture of that I just want you to kind of look through it and see where it shows you in this the little picture of lungs and your trachea and all that stuff. See the little epiglottis there at the top and your external ear over on that guy. There's the elastic, so it's probably the least abundant, I would say. And then, of course, the hyaline is the blue, and so it is pretty well spread out. It's hard to see, but it is even, in the joints in your fingers and way down there in your toes. And then the elastic, notice big parts in your spine, or excuse me, not in your spine, sorry, the fibrocartilage in your spine and your knees. That's usually considered the strongest of the cartilage. Okay, so now bone tissue. There's a couple of types of bone tissue that we're going to look at. And the first is compact. This is when you think of a skeleton and you think of just the white, smooth, that's the compact bone. That's usually the outer covering. So that's what we see. And it has a very specific internal structure. If you look at a cross section, you see this, what is labeled on the picture as the Haversian canal or Haversian system, which is an osteon, which is like a bone cell. And so you have this unit of bone. It has a blood vessel that comes through the central canal. And then you have these circular layers that are a hard matrix, and the layers are called lamella. And then in between the lamella, you have lacunae. Now, the lamella are little pillars. They are weight-bearing, very strong, and in groups and in especially in the circle formation, they are even stronger. The lacuna are little cavities, little openings that contain osteocytes, and this is where new replacement bone cells are being produced. So remember, all of your cells are being replaced at different rates depending on the cell. So this is where the new ones are being made for your bones. All right, so here again, another picture. Here's the compact bone. So notice up here at the top, you have that osteon again, which is just the individual pillars. So those are each called osteons. And then the canal in the middle there, in the middle with the blood vessels and the nerves. It's not as vascular as some of the other tissue, but it is living, so it does need to have that supply. And then down towards the bottom, it points out the lacuna down here, which is that space, and then actually it has the osteocytes, so the mature blood, or where the new blood cells are being made. Okay, so now the next type of bone tissue is spongy bone tissue, and this is located at the end of long bones, and we'll get to what a long bone is in a minute, but the name kind of tells you where it will be. And the spongy bone looks really random. It looks like just a bunch of needles or little flat pieces of bone, and these are called trabeculae. I'm sure that there are different pronunciations for that, but that's how I say it. And it looks random, but it's actually very organized, and you have stress lines and weight-bearing parts in there that give it a lot of strength. This is also where the bone marrow is, where the fat is. So if you have a dog or an animal, that chews on bones, that they're trying to get to the bone marrow. That's the actual good stuff in a bone for animals to eat. Okay, so now the four bone types. So the first one, long bone, which I've said a couple of times already. This is a bone that has a very specific shape, a long type shape. Doesn't have to be necessarily long in length, but it is a shaft with two ends. It is mostly compact bone, and there is spongy bone at the ends and a little bit in the center. But these are the bones that make up your arms and your legs. Now, of course, you have kneecaps in there that are not long bones, your wrist bones, your ankle bones. But the other stuff in there, even, the bones that make up your fingers. Where's my camera? So like that bone, that's a long bone. And so again, it's because of structure, not because of size. But the structure of a long bone is, first of all, the shaft is called the diaphysis. So that's labeled over here. Then you have the epiphyses, and these are the two ends. And so each end, and they have kind of a similar kind of a knob-like structure. Then you have a growth plate that's not really labeled on this picture, but sometimes people will call it this epiphyseal line, or they'll have it kind of where you have the meeting of the shaft with the epiphysis. And then you have articular cartilage, and this is covering the ends of the bones. It helps the bones kind of move, or the joints move smoothly. All right, then you have short bones. Again, it's pretty good description, but these are very kind of roughly cube-like. And they have lots of spongy bone in the middle with a thin covering of compact bone. And these are your ankle bones and your wrist bones. And so they're more specifically called carpals and tarsals, but we'll talk about that more when we get to the actual skeleton. Now, one kind of special one to note is the sesamoid bone. It is actually like the even fancier name for your patella, which is a fancy name for your kneecap. And so it is not cube-like, but it has more of a rounded shape, and it is embedded down into the tendons that connect your upper leg to your lower leg. And so it's kind of a specialized short bone. Then the flat bones, again, pretty good description. So these are compact bone on the outside, of course, with a very thin layer of spongy bone in the middle. They're flat, as the name implies, but most of them are somewhat slightly curved. And so you see, so here are the flat bones over here. So you see the sternum, which is your breastbone, the bones that make up your skull, your scapula, which is your shoulder blade, and then your hip bones are not pictured on there, but they have that flat kind of curved shape to them. And then the last one, they're like, okay, these all are just really random. So these are the irregular bones. And again, mostly spongy, kind of like the short bones, with thin covering of compact bones. Your vertebrae, and I'll show you some vertebrae like from a cow skeleton, so different size, but still shape is similar. Also, some of your skull bones have just a really random shape. Those are the irregular bones. Okay, so now the development of the bone. So this is sometimes fancily called osteogenesis or ossification. Embryo skeleton. So before birth, a baby is mostly cartilage until about the age of 3 months after conception. So this is still the baby's still in the mother's womb, and the cartilage starts to turn to bone. Now, it doesn't all turn to bone. Babies, are born with, of course, soft spots in their scalps, in their skulls, and then their bones are still a little bit more flexible. They're not completely ossified until you're as a total, until a person is usually in their mid-20s. So you guys are close in age to this, so you're just about there, but not quite. And so you may see a little bit more flexibility. But anyway, the osteocytes that are in within the cartilage, remember those are in the lacuna and in those osteons, they begin to take in calcium and phosphate and some other minerals. And as they take that in, they incorporate it into the osteons and into the lamella and harden it. And this is, again, just a continuous process that you finish up when you're 25 or so. And so I don't get too hung up on the picture that I have there on the page. I just kind of wanted you to see kind of how it goes. And so again, a slow process, obviously, but very, very consistent. Okay, so now growth. Growth occurs at the epiphyseal plates, which we talked about growth plates a couple of slides ago. This is where you have multiple layers of cartilage between the shaft and the epiphysis, so between the shaft and the end of the bones. And this is where you have lots of cell reproduction going on, lots of division going on, that increases the bone's length, so it gets longer. These growth plates very often are where you see break sites because of there's a little bit weak between the bone as it hardens and the cartilage that is making up the plate. So it's a pretty common break spot in some of these long bones, but it is where they look to see growth-wise. And they can even look and see if your growth plate is still kind of open or soft with cartilage. They could tell you if you're going to keep growing or not. Bones also increase in diameter, so they get wider over time. And this is due to cells called osteoclasts. And these are specialized osteocytes. And they are doing kind of the opposite of making new bone. They are breaking down bone tissue. They enlarge the center of a long bone, the marrow cavity, by breaking down that tissue to make the hole bigger. Then that degraded bone tissue is then transferred to the outside of the bone to make it wider on the outside. And so this is where you see bones getting thicker. It is a bone strengthening technique, I guess is not the best word, but your bones get stronger by getting a little thicker. Okay, so now bone remodeling. This is continuous throughout your life. So bone is continuously being removed by those osteoclasts and being replaced or formed by osteoblasts. So that's in that little picture down there. And approximately 5 to 7% of your bone mass is replaced weekly. And so over, however long we could calculate it, you have a brand new skeleton over time, and you're still reusing the parts and the cells because it's just being transferred, but it is continuous, and it is controlled by hormones, first of all, because your hormones are working to maintain a certain calcium level in your blood. This helps with cell functions and all those kinds of things. This is something that can be, that will change over time. Women in particular will see their hormone production change, and a lot of times it will affect the calcium levels in the blood so that you end up taking too much calcium out of the bones, and this is where you see osteoporosis. You will see older people, fall and break more bones, break hips in particular. And so it's controlled by hormones, and again, will change with age. It's also can be controlled by mechanical factors, by the stress that is placed on certain bones. Again, as you age, a lot of times you'll hear doctors say to an older person, you need to do more weight-bearing exercises, just, walking, jogging, some weightlifting. This tells your bones, hey, I need to be stronger, and so you will remodel in a little bit different fashion. Okay, so now bone fracture, so breaking of the bones. My picture up there at the top doesn't have all of these, but I'll hopefully describe them well enough where you can understand what it's talking about. So a simple bone fracture is just a clean break. You just break the bone. So I've never broken a bone personally, so I don't know how terrible it is, but if you're going to break one, do a simple break. A compound break is a clean break, but the bone gets pushed out of the skin. So the bone breaks and the skin breaks. That's the compound part. Comminuted, this is where the bone is fractured, so it's in pieces. Compression is where the bone is actually crushed. So you see this more with like flat bones. So you could see this with the skull or hip bones. You can see this crushing. Skull is probably the most common. Depressed, the bone is pushed in. This is a skull fracture where the part of the head gets pushed in. That's the skull. Impacted is when the two bone ends are forced into each other. So this you see very often in like head-on car collisions. If the dashboard is pushed into like the knees of the front seat passengers, that thigh bone will be impacted. A spiral break is kind of a ragged break due to twisting, and so the bone twists and breaks. And then finally the green stick, this is an incomplete break. You see this really often with younger children because their bones aren't quite hard enough. So it's just like, if you take a dry stick, it just snaps. If you take a green stick, you try and snap it, but it just kind of bends. And so that's where that green stick comes from. All right, so now if you do break a bone, it heals in a pretty specific way. And so there's 4 steps. You have a hematoma formation, which is the formation of a blood clot at the site of the break. So it's just your blood rushes there and it basically kind of hardens into a clot around the break. Then you have that blood clot being replaced by cartilage. And so you have a cartilage callus that forms. And then the cartilage, just like with bone formation in general, the bone replaces the cartilage. So the osteocytes are taking in more calcium and more minerals to harden. And then finally, you have remodeling. Very often when a bone forms, you have a big kind of a hard spot right there, and so osteoclasts come in and they kind of smooth it out. Now again, like I said, I've never broken a bone, but most people who have broken something, like if you've broken your upper arm bone, very often you can feel kind of the bump still where the break was, and that's because the remodeling is never 100% perfect. Okay, so bones. That was it for this unit. As always, ask me questions if you have them, and I will see you later.